Hey everyone, thanks for joining right before lunch. And I'll talk today about building modern applications that scale using Azure Database for Postgres and Hyperscale Citus. By way of introductions, I'm Umar. I head up our Postgres product team at Azure. And prior to this, I was the CEO and founder at Citus Data, which is now part of Microsoft as of earlier this year. And as that technology powers our Hyperscale Citus offering, which GA'd just yesterday. We'll also have one of our customers, Danny, who's sitting in the front row and will join me later on as part of the presentation as well. Before I dive in, maybe just a quick show of hands. Who here uses Postgres at all? All right, so majority. And do you use the Azure Postgres like PaaS service, which is Azure Database for PostgreSQL? Those? Okay, great. That's very helpful. Now, I'll just touch upon the broader ecosystem of what's happening, where Postgres is getting more and more popular by the day, by the year, and it's a long-standing project. For those of you who aren't familiar with it, it goes back all the way to mid-90s, actually, out of Berkeley. So it's more than 20 years and has been picking up steam steadily. And if you look at it, it's one of the most popular databases in the world, period, and has become really kind of almost an open source Oracle alternative, and that aside, a very formidable database on its own. A lot of people use it, a lot of developers love it, a lot of IT professionals love it, and enterprises love it for the same reason. And what are those? I'll just bucket them under three broad things. There is many more reasons. But first off, it's open source, right? And it's not just open source, it has a huge community of people around it. The developers, tools, language bindings, everything that goes with it. It has a reputation for being a rock-solid database, for being reliable, for not dropping your data. And there's a lot of things you might want to be experimental with in your stack, but your database is probably not one of them. And Postgres does a tremendous job there. Last, not least, is a set of features around, too many to enumerate, but if you think about, for example, basic fundamental things around a relational database like indexing, Postgres offers a wide variety, which ties into its very strong performance characteristics. Very importantly, many people know this and many people don't. Postgres supports a wide variety of data types, among them JSON-B. The B stands for binary, which is a representation of the JSON data within the database that's fully indexable. So you can actually combine your structured data and your semi-structured data within the same database, not just sitting there, but actually indexing and getting through to it very quickly. Similarly, you got geospatial data, PostGIS, text search, and a whole bunch of other things. There'll be other sessions, by the way, during Ignite that dive deeper into this topic, and I'll touch upon those at the end. But this kind of roughly sets the stage for Postgres. Now, one of the things that happens with Postgres, as with kind of other relational databases, is as you grow, your options to scale are fairly strict, if you will, and can be challenging at times. Let's put it that way. And on the left-hand side, you have this typical pattern where you have some data, and you've got more data, you get a bigger box, and then a bigger box, and then one, and then what, right? And as your data gets bigger, your indexes get larger, they're harder to maintain, your operations, whether it's backups and other things, they get more difficult, your performance becomes more fragile, all of those things. And this is not just a Postgres problem, this in general applies to, like relational databases. And with Hyperscale Citus, what we're doing is changing that equation altogether. We're saying instead of scaling up, scale out. Add as many nodes as you like. It could be 2 machines, it could be 10, it could be 20, and we'll have all of that appear as if it's a single Postgres to the application, right? And that's really the core of, like the technology that we built over the past almost like 8+ years, and that now we are kind of bringing to our customers on Azure. And there's a lot of, hairy problems underneath that makes this, difficult to build, but also very, desirable, and I'll touch upon those later on. Now, with this picture, what you're getting is as much compute as you like for your Postgres database, as much memory as you like, and as much disk as you like. So imagine, you're using a standard 128 gig VM, on Azure, and now you have 20 of those. That's 2.5 terabytes of memory available for your application, which can actually do, wonders in terms of performance. Now, when you put all of this together within Azure, what we're looking to do is really to create the world's best PostgreSQL on Azure, right? And if you think about those three pillars as to why Postgres is so popular and so prevalent in industry, we don't want to break them. We don't want to build something that's no longer open source. We don't want to break something that breaks the ecosystem, that you have to have specific DBAs, specific developers just for that. So it is Postgres. You want to leverage all of those and then add two things on top, like on Azure. One is the cloud management side, which I think many of you are familiar with, which is this kind of what you'd expect from a platform as a service offering, right? We worry about maintaining your database. We take its backups. We take its, take care of its high availability. We make sure that the security features are in there. We monitor. We do certain intelligent things, right? Recommending which indexes to put. So we do a lot of things that Azure does, and the cloud just makes Postgres better in those dimensions. On top of that, we have the unique Hyperscale Citus piece, which again, GA'd yesterday, and we're really, thrilled to share that with all of you, which gives you this ability to add more nodes anytime, right? Now with this offering, which is entirely unique to Azure, like no other cloud provider otherwise has that together, then we offer that in two flavors, to our customers. One is the single server, which is the vanilla Postgres open source deployment with all the PaaS benefits, and the other is Hyperscale Citus. There is one other point that I want to mention, which is Azure Arc, that allows us to run Postgres and Hyperscale Citus on any environment, not just on Azure. And it uses the Kubernetes infrastructure to do that. It's in early access program as of, again, yesterday. It was in Satya's keynote, as well as Rohan, Jason, and others talk about it. So if you're interested, by all means, find me, sign up online. But that's in the works, as in preview. Now, what I want to do during this talk is really spend the time on Hyperscale Citus and what it can do for you from a workloads perspective, from a use cases perspective. Also look a bit under the hood and say, okay, how is it architected? Again, at a high level, but hopefully deep enough to give you, kind of demystify some of how we do what we do. So with that, I'll give a couple of examples, and one is actually at Microsoft itself, where Citus is driving. This slide is already outdated. It's, I think, more than 1.5 petabytes at this point. But all the telemetry data across hundreds of millions of Windows devices, land somewhere. And then the product teams and engineering teams have to make decisions on when to ship Windows, what features are getting used the most. And all of that data resides in a Hyperscale Citus cluster, right? And that runs, what's really unique about it is this stores a lot of the semi-structured data, because the error reports that you get aren't always structured. There are pieces of it that are structured, like a timestamp, like a device ID, but then there are a lot of it that is different from device to device, and that gets captured in a JSON object, and then you can roll that up and serve that to make real-time decisions. And this system now gets more than 6 million queries a day, very high concurrency, high load, and a lot of the queries, more than 75%, complete in under 0.2 seconds. I think the P95, which is 95% of queries, complete in less than 4 seconds. So it's a very real-time system. And this is a difficult problem when you kind of have data at scale. And what Postgres allows is, hey, it gives you that JSON and structured data together. It gives you all the indexing, and Citus gives you all the hybrid performance around it. But it is not just at petabyte scale, right? That's one kind of extreme of things. There is as little as a few hundred gigs, and we have actually a lot of our users who start using Hyperscale Citus at 20 gigs, 50 gigs. And what happens is, one of the most precious resources for your database tends to be memory, right? And when data doesn't fit in memory, it starts hitting disk, and of course, there's all sorts of optimizations built into Postgres to do that efficiently. But still, you're hungry for resources, and with Hyperscale Citus, you can add those. And in this case, this is like a SaaS application that was able to provide more than 10x faster response times on just as little as about 300 gigs of data. One of the other interesting things here is, compared to, in this case, I believe it was Elastic who was running some of those queries before, where the read performance was kind of satisfactory at times, but the writes weren't, where you have to index the data in a real-time fashion, and then that caused a lot of bottlenecks on the system. The other piece that's important here is instead of using multiple systems of one NoSQL database for that, another SQL relational database for that, and another data pipeline to keep everything in sync, and then all of a sudden you're dealing with all this complexity. This is just simple. I got my Postgres database, and if I had 10 gigs of data, it would work fine. Now I have 100 gigs, I have a terabyte, no problem. I just add nodes, and it works fine. Right? That's how we'd like to think about the problem, and you can extend this to have 100 servers and a petabyte of data, and we want things to be simple. Right? We want all the goodness of Postgres. We want to maintain that. And looking across different industries, I touched upon a couple of examples, but even before GA, so during our public preview journey, you were lucky enough to have customers who've actually built production workloads. So they rely on Hyperscale Citus today in mission-critical ways across different industries. The first one on the left is around IoT and its applications in actually financial services and insurance. And the core value prop there is, say, I have a lot of IoT data. I want to be able to ingest it and, again, keep a simple single system to be able to do that. In healthcare, there is a lot of data that gets accumulated for patients, and there are regulations around how long to maintain them and have access to those. But that data can get large very quickly, and in this case, you could have 10 terabytes. Now, having that on Postgres or in a relational database can be a bit cumbersome, but on Hyperscale, that's no problem, and you can provision as many as you like as your database grows. On the retailer side, this is actually a very powerful use case that also incorporates AI into image recognition and other applications of AI. Again, the underlying data store is Postgres, and it is getting used to do more efficient supply chain and more efficient delivery of product. The queries in this case, compared to a single node version, were up to 20x faster, and it also, by virtue of the application, has geospatial things in it. And last, not least, there is a host of applications. You can think of them as like SaaS applications, software as a service. You can think of them as like multi-tenant applications. A lot of independent software vendors, a lot of businesses build them. And in this case, and we'll dive into that later, you can get both scale and a large Azure ecosystem using Azure Database for Postgres. All right. So now I want to dive a bit under the hood. Questions so far. We'll have a Q&A at the end, but I've rushed through some of the earlier slides to kind of give more in-depth view into how we're doing the real-time analytics and how this works. Anything I can answer? You're actually, the question is, hey, are we scaling the databases or the server? And I'll get to that in the kind of multi-tenant piece, but you're actually having multiple instances of Postgres running, but they appear as a single database. So that complexity of having multiple databases is hidden from the application.
Can this Citus be used for both batch and really low latency OLTP transactions?
That's an excellent question. The question is, can it be used both for batch and low latency transactions? And in fact, the answer is yes. And in fact, that's an area where Citus really shines. Because you can keep data at a low level, low latency. You can fetch records in a matter of a few milliseconds. So it's a transactional, it's an operational data store. But by virtue of having lots of nodes and being able to parallelize things across, it can give very fast analytics performance. So especially workloads that combine the two are a sweet spot. All right, and I'll get a bit into how we do what we do, which will answer also some of these questions. The way really Hyperscale Citus works is there's a coordinator node, and you can have more of them. You can have replicas of them and others, and then you have data nodes. And when you get a query, for the application, the endpoint is a single endpoint, and which is a Postgres. Each box here is a Postgres instance. And the latest version of Postgres, which is version 12, is supported, as well as 10 and 11. And when we get a query, then we look at it, the optimizer does, and says, hey, does it need to touch all the data that's running across machines, or can I get it from a single location? And then it plans it accordingly, it executes it accordingly. And in this case, a single select can be farmed out as many selects get the results back. Now, there is a lot of detail behind this, which I won't go into, but I'll give an example of what type of challenges you might run into. For example, let's say it's not just a select. Let's say you want to update the database, or you want to update the schema, right? Let's say you want to add a new column, and you've got data lying around in these 10, 20 machines, and then you've updated your schema on 11 of them, and on the 12th one it failed, for whatever reason, network blip. Then what do you do? Like, is your database consistent? Is it inconsistent? How do you roll back? So these are types of questions that, as an application developer, you shouldn't have to worry about. Like, this complexity your database needs to take care of. But because these are hard problems, they've traditionally been addressed in the relational world as a single node that just scales up. And with Hyperscale Citus, we're actually solving those problems and changing the game, really. Right? So that's what's happening underneath. And when you add new nodes to your cluster, which is one of the things you want to be able to do, since you're running in the cloud and you have more data, I just want to add more. And in the interface, it's simply a slider, where it says 8 nodes. You drag it to 12, and now you have 4 more nodes. What happens then, right? Do I take downtime? Do I redistribute my data? The reality is you get no downtime, not for your reads and not for your writes. And the way we do that is we take each of these little blocks of data, which we call shards, and there's many of them. There can be tens, hundreds, sometimes thousands of them in that cluster, and we'll move them one at a time. Underneath the cover, we'll take them to the new database that we've just provisioned for you. And then because these are smaller chunks of data, that's an easier operation to complete. And then once that is done, then we cut over, we switch the metadata. So the application doesn't know that it's gotten added more resources. In fact, it doesn't care, right? Like the application shouldn't have to know that I have more resources underneath or less, that shouldn't have to change the logic. And we'll do that kind of under the covers. And this type of entirely online scaling behavior, not with minimal, but literally zero downtime, is something that's very unique to Hyperscale Citus and very unique to the industry, actually. All right. Now, there are different types of scaling, and you might have run into them, heard about them, but I'll talk about the two that are most relevant here. One that's about storage scaling, and one that's about compute and memory scaling, right? And for those of you who, for example, have heard about the Hyperscale SQL offering as an example, which would fall into scaling the storage aspect of it, right? So what happens there is you're getting more storage, a shared storage layer that gets attached to each of the databases that you're operating, right? But each of the databases are a replica of each other. So you have one shared storage layer, and then you have replicas of the database. And what that gives you is more storage. So if your database size gets bigger and bigger, you can attach more storage to it. However, every query that runs hits a single endpoint, right? And then it hits a single compute instance. It doesn't get kind of across compute instances. With Hyperscale Citus, what you get is a shared nothing architecture, which means you're looking at each of the data nodes as a unit, as a VM, which has its own compute, own memory, and own disk, right? And you could have 2 of them. You could have, again, 100 of them. What that allows you to do is have as much memory as you like and as much compute. So again, take an example, 128 cores. Take 100 nodes. You have actually even with 10 nodes, you're more than 1,000 CPU cores just on a Citus cluster. For again, those of you who are familiar with like variants of Postgres that are forks and proprietary versions like Aurora, for example, on the AWS stack, it would very much fall on the left-hand side of this. So it would give kind of a shared storage. But then to give an example, let's say you scale to 30 terabytes of data on your Postgres instance. You still have 256 gigs of memory and a bunch of compute. Try running a count star. Try running a some query that touches upon that data. You're still bound by the resources of a single database, even though you have storage. So you literally have to fetch all of that data, count it, give it back. But again, the application doesn't care. You don't care so long as there is performance, but performance takes a big hit. Right? So those are some of the problems we solve with the Hyperscale Citus that's very kind of native to Azure. All right. For the use cases now, in terms of, given this is the technology, and this is kind of how it works under the hood, there are three main buckets that I'll talk about of how you can put Hyperscale Citus into action. One of them is the real-time operational analytics type of application. This goes to the earlier question where it's a typically mix of both analytics and transactions, hybrid operations. And oftentimes, different solutions are thought of for this space, sometimes in memory databases or sometimes what's called HTAP, hybrid transaction analytic workloads, come into play because these tend to be very compute and memory intensive. And again, given the architecture we talked about, we can really easily scale to that with all the Postgres features. The second one is the multi-tenant and SaaS applications, and this applies to a broad range of applications, almost not all, but I would say almost all, like B2B applications fall into this category, right? So if you're a business and you're serving other businesses, then it's very natural to think of, hey, I have tenants that I serve in my database, and Citus has a whole set of functionality around it that makes this possible. Again, we'll touch upon that later. And last and not least are these high-throughput transactional applications, where you've built a relational application using Postgres or using Oracle or some other database, right? And then you've rely on the semantics of a relational database. You perform joins, maybe you perform transactions in the database sense of the word, and you just have too much data. Right? Then what is too much data? Like I said, it could be as few as 100 gigs. It could be a few terabytes, but enough that you're having performance problems, enough that you're having maintenance problems. And in those cases, again, we preserve the relational semantics and offer a transactional database that operates in the cloud. For talking first about the real-time operations use case and how really that flows, this is a kind of a sample app, if you will, and I'll kind of walk through how you can build it in the context of Azure, and then again, this is broadly applicable, where I have data being generated through my devices. It could be IoT, it could be patient data, it could be like manufacturing data, doesn't matter, and that could arrive directly into the database, or in this case, there could be an event hub that queues that data up. It could be a Kafka queue, whatever, where the data then just lands into our database. And one of the nice things kind of in this picture is each of these integrations, because Hyperscale Citus is Postgres, exists, right? Like we don't have to build a custom integration for everything. Almost all solutions out there have a driver that talks to Postgres, right? And this applies in the visualization with Power BI, with JDBC connectors, with language bindings. All of that is kind of intact. Now, the data arrives into the queue, and then it lands in Hyperscale Citus database. Now, here we show two types of tables in there. This is as a simplification. Of course, you could have hundreds of them if you wanted to. But the idea is you can store your raw data as it lands. directly from the queue or directly from the source of information. And then you could run these batch jobs, which is that kind of time clock over there. Every 5 minutes you could aggregate the data. Every 30 seconds you could, or every day you could. And then that gives you your raw data and your pre-aggregates together in the same database without having to ETL this data, put it into a different store, do a batch jobs and put it back in, because you have all this compute available. You have all this resources available, and if you need more, you can drag the slider and get more, right? And then with that, now you can build an application. You could be using the app services here, kind of at the bottom, or it could be kind of directly writing SQL. You could use a framework. You could use .NET or Ruby on Rails or Python and Django or whatever is like most suitable for your purposes, and then serve the application directly off of your Postgres or Hyperscale Citus database. And they can push those into real-time notifications. Again, this is a transactional database that will allow all of those to happen. Now, if there are things that you want to do that away from the database for any reason, you can certainly do that. In this example, that could be Azure Database. We fetch the data. You could run kind of ML jobs, put it back into the database as needed, right? And if you think about it, like much of this is optional, right? Where you might have an event hub or you might not. You want to have Spark or not. You might have pre-aggregations or not. But in all cases, you need a database. You need a database that keeps the data, that serves it in real time. And what Hyperscale, Citus, and then Postgres allows you to do is, use that transactional core with all this scalable capabilities. So each of these pieces in the chart, that's one of the beautiful things, now scales. Like the event hub, you could add as much as you like. The Spark cluster, you could add as much or as little as you like. App servers, again, same thing. And prior to Hyperscale Citus, the database size was that wasn't always the case, right? As you could get some of these characteristics with NoSQL databases, but not with Postgres, not with relational databases, and we changed that picture. All right, so this is really the crux of how you get to this. For example, you were talking about the Windows use case, how the telemetry across more than 800 million devices, end up in an architecture kind of like this to give real-time insights. This is how it gets done, right? And under the hood, you can still do your joins. You can do all of that, performance through the Citus engine. Now, next use case I'll briefly touch upon is the high throughput, transactional applications, and this goes into this ability to use Postgres as my engine, and then have as much storage and compute as I like. Like I said, the relational semantics is what's really important. If your app relies on joins, if your app relies on strong consistency, on foreign keys, things that are relational in nature, which are, by the way, very useful things. They don't exist as just legacy, but they serve a purpose. And if you just want to scale that transactional throughput, Citus ends up being a very good option. And with that, I'll switch first to the multi-tenant use case, the third one, where again the architecture is generally the same, where you have data that comes in, and then this application could sit anywhere, and the database service could sit anywhere. In this case, we give the example of Azure Kubernetes service, but really, it could, be whatever you like, and the language frameworks of your choosing, whether it's Ruby or Django, any of those things will work as is. But instead of talking to this in a lot of detail, I'd like to invite Danny to the stage, who is like one of our customers and really has, lives this problem and lives this challenge and lives this solution. So thank you for being here.
Thank you, Umar. Yeah, appreciate it.
So perhaps just starting, with Finastra, could you tell us a bit about what Finastra does and sure, how you go about it?
Yeah. So Finastra is one of the largest worldwide fintechs. We have 10,000 plus employees worldwide, and we service banks and credit unions, financial institutions. And we also service other fintechs. So we built a platform that we're very proud of called fusionfabric.cloud, because we believe that the future of banking is actually open. This is something for some of our European friends that are here know that in Europe, there is already large open banking initiatives that are underway. And at some point, they will make their way into the US. And so we're preempting that, and we're building technology that enables banks, fintechs, and their customers to be able to interact more freely than they have been able to do in the past.
Gotcha. And as you do that, Danny, of course, data sits at the center of it, and you think about the kind of modernizing that and taking that into the cloud. How are you thinking about that problem? Are you taking things wholesale? Are you taking kind of a more iterative approach?
Yeah, good question. So Finastra is obviously a large organization with lots of disparate products. And so we've undertaken a journey, we call it a cloud journey, to move portions of that portfolio of products into the cloud. And they're all taking sort of a different maturation process. We really kind of define that process as sort of two steps. The first step is kind of an infrastructure as a service, and then it's sort of a traditional lift and shift approach, and then taking advantage of the second phase, which is cloud native. So infrastructure as a service is where we've done some things like you showed here, where we've moved the storage layer of the database into its own dedicated component, and then containerize the entire application or suite of applications, move them into Azure. And now we're excited to work with the Citus team on the next phase, which is taking advantage of some of the cloud native functionality, specifically in the data layer.
So to that point, Danny, when you think about a multi-tenant application or a SaaS application, that many people don't think of that naturally as, say, that's cloud native.
Right.
How did you think about that problem, and how did you kind of pick Hyperscale Citus for that workload?
So we primarily were using this in one of the technologies within Finastra. It's a digital banking technology that was based on a company that started over 10 years ago. And like many companies, we built an infrastructure, and we based that infrastructure around a multi-tenant Postgres instance. And as we grew, we decided to obviously need to scale this database. And at some point, scaling turns into a conversation that leads in the architecture direction, right? So there's always the throw more hardware at it approach. And then there's the architecture approach, right? Are we doing the right thing? Yeah. At somewhere along the way, NoSQL and some of these other approaches became part of the conversation. And what the architecture teams discovered was that what that was intending to do was actually to force us to re-architect a whole lot. So learning about the Hyperscale Citus solution gave us the opportunity to maintain our relational structure, and we'll get into that in a second, and make basically a minimal amount of change and get a maximum scale out the other side.
Makes perfect sense. And I think you have some content to cover.
I do.
Step aside for a sec. I'll be back at the end.
Great. So I have some specifics then on the journey, right? So at the inception of this application that we're talking about, won't sound shocking to any of you all, right? We had several tenants. We built it with multi-tenancy in mind. Hundreds of users at that point, end users, tens of tables, and a set of basic transactions. We moved that, obviously, as it continued to grow. That same multi-tenant model grew into the several hundreds of tenants. Tenants for this application were a financial institution. Those financial institutions' end users, so these are the people that are logging into the application, the bank or credit union's customers or members, were our users, and they quickly grew into the millions. And what we ended up with was a multi-terabyte database. And this database actually didn't even hold all of the information. In lots of cases, we would pass through the application onto these banking core systems, which actually maintained a lot of the real time. And so, as I said, we were faced with this challenge. How do we continue to scale this? As Umer mentioned, scaling storage is one thing, and that the cloud providers and everything along those lines, and even the colo providers, came up with great solutions for that, right? SAN storage, localized shared storage, but the compute was starting to be the issue. So where did we see this thing going? As I said, rip the entire thing apart, start from scratch. As we were on a microservice journey, breaking up parts of a monolithic application, the microservice journey and that whole cloud native approach comes to kind of a screeching halt when you get to the database, right? And even within microservices, when you talk about a database per service, some would argue that that is actually a way of getting around this problem. So we were faced with the fact of having to fundamentally change the way that the application worked. So we looked at certain things. As we were moving everything into the cloud, we needed to minimize the application changes. This is a real-time application. You as an end user, when you log into your banking application, you expect it to be always on. So we had very high needs in terms of always on and availability. Maintenance cost. How do we maintain this thing and pay for it? Adding nodes with zero downtime. So if you scale, as you start to scale out, we need to keep in mind that this is obviously a real-time system. And tenant isolation was very important. So in the banking space, even when you have a multi-tenant database, you have to present to regulators and to your banking customers that their banking data is not improperly commingled with other banks' data. So how do we do that? So as we looked, and this is an example of our thought process, scaling using NoSQL, we just took that off the table. We had to fundamentally change the architecture. We used to call it, changing the wheel on the car as the car is driving. That's a metaphor that's very apt for us. Solving scaling needs by switching to a NoSQL would be like changing all 4 tires on the car at the exact same time while it's driving. So that wasn't going to happen. So where we landed was on the Hyperscale Citus solution. That the aha moment for us was really a couple of things. The first thing is when, as Umer showed on one of his slides, that coordinator, that single endpoint, all of the application architects in the room jumped up and cheered because now they understood, the fundamental pieces of the application stay intact. When you move to some of these other database structures, it's not so much the work to re-architect the database as it actually is to change the way that your application is actually behaving. And when you have an ORM-based application where there's a very tight tie between the objects in the application and the tables that they're related to, you see how this quickly can turn into a large-scale effort. So we were able to not have to do that because this coordinator service and set of services still have the application treat it like it's one database. It's still talking to one database. Adding nodes on demand, as Claire in her demo yesterday in Rohan's session showed, a simple slider to be able to add nodes, to have that data fix itself along the way. So as you add nodes, you don't have to have a separate process where you're then having to manage data moving across into these brand new spun up nodes. The application sort of takes care of that for you. And then again, tenant isolation. And for us, we want to get a little bit more sophisticated with this. And the product actually gives us the ability to do this. You can have a tenant on a node. You can have a tenant on a set of nodes, or you can have multiple tenants on a node, or multiple tenants on a set of nodes. And that works for us because we have certain tenants who have a very, very high throughput. They're in the hundreds of thousands of end users logging in every day. And then we have other tenants that have 10, 15, 20 users logging in every day. So if we were forced down this route where we had to have a node per tenant, then we would be obviously having another scale issue, which is one of the specific nodes is just not serving our larger tenants. So this tool gave us the flexibility to be able to do that and to treat the tenants elastically. So we're excited about it. It's in the middle of development as we speak. We're targeting production early next year for this. And again, the database teams are excited because they finally will get to be able to properly scale. They don't have to learn or change an architecture. And the application teams are excited because it's a minimal amount of change, and they're going to get maximum scale out the other side. So that's us. Umer? Flip this on.
Thank you, Danny.
Yep, appreciate it.
For sharing that journey and being part of it. Yeah, with that, we're at roughly, I think, the top of the hour. We have 5 minutes for questions, and happy to take them. Yep. Mm-hmm.
Then when it comes to the cost, comparing this to Cosmos DB,
Mm-hmm.
how do you compare that?
It's so the way I would think about it is if you're building a new application, and if that application is, I'll talk about the relational, non-relational side of it first, and then the cost. Well, let me address the cost side of it because that's more straightforward. You know, this is one of the nice things about Postgres is it's open source, right? And so there's no licensing cost on an ongoing basis. What we have is you pay for the VM, and then you have for the PaaS service, and I think it starts as low as less than $50 a month, you know, to get started on Azure Postgres. So literally, like right now, you could go and within minutes go to the Azure portal, click a button, and get this instance of Postgres running, and then you could get a Hyperscale Citus instance again, like within minutes. So that's from a cost perspective, extremely manageable. Now, from a why you would want to use it, like one versus another, I think it revolves around the type of application that you're building. Right? And in cases where it makes sense to like leverage relational semantics, multi-tenant applications like the one Danny talked about is an excellent example of that. There are like many others. Like if you're doing joins, then like the question is, say, do you want to denormalize everything into these large tables, or do you actually want to leverage joins? And because your database now gives you that capability in a distributed fashion. So then I think that leads one path or another. And then if you're kind of on that relational path, Postgres is an excellent choice, has all the scaling with Hyperscale Citus. And if you're kind of on a NoSQL path, Cosmos DB is an excellent choice. Yeah.
How do you enable you to jump in and fix problems when things go wrong? You said a lot is managed under the hood for users.
Mm-hmm.
I'll give you an example.
Thank you. Okay, then I'll repeat too, yeah. Mm-hmm.
And therefore that works. Therefore the user needs to jump in and manually tweak the partitioning.
Yeah, yeah. Right.
So when things go south, how do you enable users to jump in?
Sure. So I'll talk to that example, and then there's a kind of a broad set of, it really depends on what the issue is, right? But if you think about Postgres as a database, it's both a storage framework and a computation framework. So you do stuff in the database, you compute. Spark is a computation framework. Right? So it doesn't actually store the data. It pulls stuff into kind of RDT, and it runs in that sense. It gives ability to process that data. So with the database, because it is serving both storing and serving the data, we have to be very specific about the guarantees we give to the application, and we have to honor them all the time, right? As an example, like you can't be in corrupt state. Your indexes, your data, so those type of issues, Postgres addresses them, and we manage that as a service. So like there's a lot of built-in controls, and that's the reputation of Postgres, for being able to handle those things. Now there are when you talk about issues, there is so many of them. You could, run out of memory. You could run out of disk space. You could, like have connection, like issues, all of those things. And we, in our PaaS service, which is, Azure Database for PostgreSQL and also with Hyperscale Citus, we do all of that management using a kind of a control plane and a data plane to automate as much of this as possible. What that means is when a node is down, we'll detect that. We'll fail you over automatically. We'll monitor it. We'll give alerts, like when disk is running low and other things. If you accidentally drop a table, and you can't believe how many times this happens. And then you're in the production database and running it, instead of connecting to the dev cluster, you connect it to your production cluster and you drop the table. Now, you have point-in-time recovery, as any kind of good, relational database has. Like we have that capability. You can go back to, 6 days from, today to this hour, and then extensiate that in this region or a different region in Europe. All of that is part of the PaaS offering. Now, that doesn't mean we can tackle every issue, right? And so to the extent that you're operating the database, to tune its performance, and you might need some DBA attention, if you will, much like you would have. But a good chunk of that work is fully automated: security, patching, backups, all that. I don't know if that answers your question. Yeah. Mm-hmm.
So as we start using this whole sharding concept, right? One of the main objective to use is to scale out your queries, where you have distributed data. So does this provide the ability to do data distribution based on, like, you can decide some keys which you want?
Absolutely. So you would basically take so the question is, does this database allow me to distribute the data using a particular key, right? And the answer is yes. So in fact, how Citus works is, you would take a table and you would say distribute by a key. And a multi-tenant application, the key would typically be the tenant ID. So you kind of, and as an example, or it could be like a device ID, something that you pick, and then you'll distribute the data, and your application then doesn't need to, know about that, just issues its select query, and we'll do the rest.
Okay. And so then there are some data which are more like metadata or general data which is used by, required for all the queries, where you really want like replication.
Yes, and that's the other mode where for that data that needs to be addressed across multiple nodes, we keep a copy of it on all machines.
So in the same database, you could decide some tables where you want the distribution.
Exactly. That's how it works.
So one last concept in this direction. So when there are situations like GDPR regulation, where you want data geolocation, maybe a multi-region. So I'm assuming that Postgres Citus in Azure allows for geographical, like multi-region of Azure. So can we achieve such things where you can have particular data, like for Europe and data only in the Europe region?
So that's a more the technical and a practical answer. The practical answer is, you can set up a different Citus cluster for every region where you want to, keep the data local. Technically, Citus engine itself has the ability to, through tenant isolation feature that kind of Danny pointed out, you could say this tenant, I want to isolate it to this machine, and that machine is in Europe. Right? You could tell the database to do that, but by default, in the service we offer, we don't do that. We will ask you to pick a region, and then we'll deploy the cluster there. So that's how you would solve that problem. All right, and with that, we'll go. One more question. Sorry. Yes.
We are also in a situation where we've got this monolith with a really bad designed SQL database.
Mm-hmm.
And also we need to change the real world car still driving. Is there any benefit of actually moving that to Postgres and sort of getting the scaling that's with this badly designed database?
Yeah.
Of the sharding and stuff like that. And is that a feasible solution for sort of buying some time while we are decomposing the monolith? We can't fix the database. That's basically it.
Yeah. So we can. So we have a database which we can't fix, and in this case it's a SQL database. What can we do to either buy time or solve this structurally? an accurate answer requires more context, like meaning like it really depends is the short answer. Maybe to give some structure, like I would put things that matter the most to you in terms of like how kind of like Danny laid it out, and it could be the same things, it could be different things. Now, what's going to happen in your calculus is the migration of an app might maybe take, because you're changing the database engines, it might be more work than staying on the same engine. But then the effort, you're still in the relational framework. So you don't have to decompose this into, different, microservices, each of which are different NoSQL structure. You preserve the same. So if you think about this effort as your continuum, maybe your effort, this is zero effort, and then, this is entire re-architect, and this is zero effort. I click a button and everything. Maybe you're here. And maybe that's okay. So then, and then you incorporate that and you take into account, hey, the cost of operation going forward. Hey, this is actually a familiar stack, relational, and then the calculus might make sense. In another scenario where you've built everything, what we see a lot of actually is Oracle to Postgres migrations, very heavily, because the Postgres syntax is very close to the Oracle syntax. And the stored procedures, everything are kind of modeled after that. So when those workloads come in, again, because it is relational by nature and it's open source, it's a very natural fit. It might apply in your case, or happy to talk offline. All right, and thanks for coming, folks. We have a series of sessions the rest of the day. If you're interested, including, I'm not going to talk through all of them, but why Postgres. Craig has a great talk on, what makes Postgres so popular. Or the next one is, Sunil's session actually coming up at 1:15, where we're looking into looking across open source databases, MySQL, Postgres, and MariaDB. Manish has a very interesting session, which I'll be there for, which is running MySQL apps with Azure Kubernetes and app services. Sarah in the back has a session on migrating Oracle to Azure Postgres, and a host of other things. So if you're interested, by all means, we are here to help. We have a booth, and just let us know. Shoot an email, ask Azure Database for Postgres, or find any of us. Thank you.